15. How much and in what direction will each of the following affect the rate of the reaction? And then we have carbon monoxide gas, CO gas, plus NO2 gas, which will yield CO2 gas plus NO gas. And they give us the rate law, right? The rate law for this reaction is rate equals K times the concentration of NO2 squared. So right off the bat, before I read A, I'm just going to rewrite the rate law, because chances are if they gave it to me, that's going to be pretty important. So rate equals K times the concentration of specifically NO2 squared. Now, when they give you a rate law, this predominates over the balanced equation. If you already have a rate law, you have to use the rate law no matter what they say as far as what the reaction's going for. The rate law overpowers the balanced equation as far as doing your calculations. So now from this information, we're going to find out the effect of the rate when we're going to decrease the pressure of NO2 from 0.5 atm to 0.25 atm. Okay, so now they gave us a unit of pressure here, right? We're decreasing the pressure from 0.5 atm to 0.25. However, the rate law is written in brackets, and generally speaking, brackets means concentration. So, which basically means molarity. But just know that you can use concentration or pressure values for your rate law. So you can use molarity, which is your concentration, or you could use your ATM values for pressure. But generally speaking, if you do see the brackets, it's just written in concentration units, but you could plug in your pressures like they have here. So now the whole thing is we have to find out what's going to happen with the rate. Well, it seemed like my initial pressure, right, my pressure for NO2 initially was 0.50 atm, and then over time it went down to a pressure of 0.250 atm. Well, what happened, right? Well, from 0.5 to 0.250 seemed like we cut it in half, right? If I take 0.5 and I divide it by 0.25, I get 2, which means that 0.5 is 2 times more than 0.25. So if I wanted to go from 0.5 to 0.25, I would divide by 2. And this is the same thing as timesing by a half. So in essence, we took our 0.5 pressure and you just dropped it by a half. You are decreasing by 1/2 or 0.5, doesn't really matter, whichever one you prefer. If you like using decimals, use the decimal. If you like to use a fraction, use a fraction. So now, once we're using this rate law, you can use your rate law for your change values. So we don't really necessarily care too much about where we started and where we ended. The only thing that we care about is what factor we decreased by. And from 0.5 to 0.25, you're dropping by 2, right? You're going down by 2. So, and now since I look at this, going down by a half is basically the same as going up by 2, right? So what I'm going to do is maybe I'll just get rid of this and we'll just go by this value right here, times it by a half. That's our factor. Okay. So now, when we have our rate law, rate equals K times the concentration of NO2 or the pressure, right? The factor that we're going to be using is going into our number for the NO2. So you don't care about, 0.5. 0.5 isn't going to go in here, and 0.25 isn't going to go in here. The change is going to go in there. So whether you want to put 0.5, that represents a half, or you can put in, 1/2, that's fine. Doesn't matter to me. I'm going to put in 1/2. Okay. Now, we still want to find out what's going on with this rate. So if we put a change in for the reactants, a change, what's going to happen to the rate is going to come out, right? And the only reason why I could plug in the 1/2 for my rate law is because the concentration and whoever it was matches. But if they give you pressure values for someone and it's not in the rate law, it doesn't matter. It doesn't work. Now the only thing that's left is this K value. Well, a K value is a rate constant. But just know that rate constants are never going to change when you change your molarities. They're going, or your pressures. They're going to remain constant for that specific reactant. So, or the specific, rate of reaction. So for your equations where you're changing your concentrations or your pressures, the K value doesn't make any difference because it's going to stay the same. So it has nothing to do with the change. So we can basically get rid of this K value and make it easier on ourselves. So now let's see. We have rate equals 1/2 raised to the second. And we can do this math, right? If we take 1/2, and if it's raised to the second, that means that I have 2 1/2s being multiplied by each other. And when you multiply by fractions, remember, the tops get multiplied together and the bottoms get multiplied together. This is not cross multiplication. So 1 times 1 is 1, and 2 times 2 is 4. So your rate is going to come out to be a change of 1/4, which means that if you're dropping the pressure by 2, the rate is going to drop by 4. So that's basically the answer. What is the rate? How is this going to affect the rate? The rate will decrease by a factor of 4, or you could say decrease by 4 times, or decrease by 4-fold. This 1/4 just means that you are decreasing. It's not rate equals 4. If it was just rate equals 4, then you would say the rate would have increased. The 1/4, or the fraction, just means that you are decreasing. So chances are if your change is a fraction, the rate is going to be a fraction change, and that means decreasing. So maybe what I'll do, just to keep everything on the same, there we go. And we're going to put that there. So the rate will decrease. It's going to be going slower by 4 times the amount. And I think that's it. By how much? By 4-fold, by 4 times, by a factor of 4. And in what direction? Well, it's just slowing down. So still, your reaction is going to be going to the right, but it's just going to be going down at a much slower rate by 4 times. And that's the answer. What'd you think? I hope this helped. Let me know in the comments. Thank you so much for viewing the video. Subscribe to the channel, and I look forward to helping you in more questions. Have an awesome day. Keep studying hard, and always keep learning. I'll talk to you soon, okay? All right, bye-bye.